So extreme gradient boosting is an algorithm which has parallel processing capabilities, GPU support, and distributed. In distributed environment also it works. What do you mean by distributed environment? If I have 800 terabytes of data, can I store it on a single computer? No. I need to store it on multiple computers or multiple servers. When you store it on multiple servers, you want your algorithm to access the data which is there in different computers, do the processing, aggregate, and give you the results. That's called as working in distributed environment. And extreme gradient boosting can also work in distributed environment. And it has helped many machine learning engineers and data scientists win Kaggle competitions. It provides an interface that resembles scikit-learn's interface. So that is the reason why it is even easier for you all to understand and implement that. And it gives you very, very fine control through its hyperparameters. Okay, it has huge set of hyperparameters. It will give you access to all of those to have a very tighter control on the experiments that you perform. Okay. It supports monotonic constraints. That is, the predicted value should only increase or decrease relative to the specific feature, right? Specific to, you can have a control on your features, basically inputs. Okay. And then you can also have feature interaction constraints. What do you mean by feature interaction constraint? If you have two variables, one is say output on how is the response of a patient given the dosage of a medicine. Say you're providing some dosage of a medicine, some injection or some oral medicines. And here probably gender also comes into picture, because based on whether you are male or female, maybe the dosage quantity has to increase or decrease. So that means there is an interaction between these two variables. That means when I build the model, I also need to have another variable, which is x1 into x2. This is called as interaction variable. When you do your exploratory data analysis properly, you will be able to understand whether interaction variables are needed or not in your algorithm based on your common sense. Here, okay, dosage level of the medicine varies based on your whether you are male or female. If you have that prior knowledge, include an additional variable which is called as interaction variable. Okay. I will briefly talk about certain hyperparameters as well. Okay. So can we use gradient descent algorithm for both regression and classification purpose? Yes, we can. Yes, we can. Can I use AdaBoost for both regression and classification purpose? No, you cannot. AdaBoost is only used for classification purpose, whereas gradient boosting and extreme gradient boosting can be used for both classification purpose as well as regression purpose. So extreme gradient boosting can handle the missing values automatically. You have a hyperparameter. Okay, within extreme gradient boosting, the moment you select that hyperparameter, the missing values would be automatically replaced or imputed. Okay. And when you provide the data to extreme gradient boosting, it will try to apply different split options what it will do is it will apply different, techniques to impute the data, and it will try to apply different split options. How do I split the basically branches? Okay. And then after applying different techniques, it will then figure out which technique is giving the best result. And it will automatically take that best result and give you as an output. So it has that inherent experiment capabilities. Even if you do not mention, it will automatically experiment. And this is another reason why in majority of the auto ML techniques, like SageMaker, Microsoft Azure, machine learning services, Google Cloud Platform, all the auto ML capabilities, if you run an experiment, that's also there in your curriculum, by the way, right? As part of your masterclass, that also would happen. You learn about SageMaker Autopilot. Without writing a single line of code, how do you execute all the algorithms? That's one thing. Microsoft Azure, you just drag drop. You won't write again a single line of code. Same as with Google Cloud Platform also. When it experiments thousands of algorithms, it will use extreme gradient boosting or neural networks. That's it. This algorithm, extreme gradient boosting or neural network algorithms. Okay. Yes, Savish. You can use PySpark also. Yesterday, I think there was a master class, right? Master classes we intend to conduct every month. So don't you worry if you miss out on anything, again, you can attend that. But attend because it will give you huge knowledge. Whatever your knowledge that you're accruing as part of the training is on one side, and the master classes are on another side. Only when you combine those two, it will give you rippling effects. Okay, so is there anything else? Okay. So how does extreme gradient boosting get the speed? Because boosting algorithms cannot be used for parallel processing. The reason being, the next iteration is dependent on the previous iteration. The output of the previous iteration will go as input to the next iteration. Despite that, how extreme gradient boosting is being used. So XGB was specifically designed for data scientists to experience huge speeds. So speed gains allow machine learning models to build more quickly, especially when you deal with millions, billions, or trillions of rows. Even if you have trillions of rows, huge data set, extreme gradient boosting will work because it works on distributed environment also. Okay. So it uses something called as approximate split finding algorithm. And here also, underneath the hood, there are decision trees only which are running. And decision tree runs on which algorithm? Greedy algorithm. And gradient boosting also, extreme gradient boosting also uses greedy algorithm only for splitting the tree. Meaning it will find that variable which has the highest information and it will choose that as the root node. And then it will split. At this step, it will look at again out of the remaining variables, which variables have the highest information gain, and again it will use that as a reference to split. Greedy, because it is only going after variables which give highest information gain. Hence, it's called as greedy algorithm. Okay. Another difference is when it comes to split finding algorithm, it uses something called as quantiles or quartiles. Already in Voxplot we discussed, right, about 25th percentile, 50th, 75th percentile, 50th percentile, etc. These are also called as what? Quantiles. Okay. Then when you find time, just explore this specific algorithm, quantile sketch. There is something called as quantile sketch. And this is the algorithm which was actually improvised in extreme gradient boosting. People have taken this quantile sketch algorithm, which was previously being used, and they're trying to improve upon this. Okay. And if you look at XGBoost paper, I'll share the link with you all. You'll find all the math calculations, algorithm, derivations, and all that, right? If you are interested.